I have found a way to find a squared circle in a plane. Um, I had a couple of ideas and it led me to this. There was a reverse engineering process, if you will. And when I got to this stage here, I realized how simple it was. And, according to my calculations, it, it, it seems to be accurate. Um, it, Somebody else, of course, could verify this with their precision accuracy that technology has to offer today. But um, as it is, um, I tried my calculations of finding an equal size square to an equal size area of an equal size square to the area of an equal size circle, both with um, the number for pi, for the circle, a equals pi r squared, and the pi that you have on your calculator is um, a 3 point, a certain decimal, and then you have 22 divided by 7, which is 3 point 142 or something like that. Anyways, like I just went with the one on the calculator. I'm going to take it for fact that that is the more accurate number for pi. Um, but um, okay, so this is where I got to, and I'll show you how how my logic was deriving to get there. Um, I I was doing something else. I was trying to make more creative geometrical designs, creations, and stuff like that. And I was doing something with 7/4s in this arrangement, and then I just kind of, it caught my eye where it was like, hey, what happens if you draw a square through those points, right, in the sevens, and then draw a circle around the outer tips, and I was like, hey, wow, that's it. It's close, like just visually looking at it, it's close, but it's not quite there, and that's what led me to this thinking process. I was like, oh, well, maybe there's another way, a simple way, if you will, of finding a squared circle in one plane, right? In a plane, in a plato, which ironically is also the name of Plato, who was also very interested in geometry, and I believe a plato in Italian also means a tray, like a tray, like a serving tray. Interesting, interesting. But anyways, without going too far off topic, so that led me to this one. And sorry, I did not erase all these lines here. Just showing you my kind of more crude work here, if you will. Let's actually move it that way because the other one's not that accurate. But so I thought, well, let's arrange nines in a similar way to the way I just did with the sevens, where you have four nines like this, and they share the a four-sided square, and then I drew a line going through those two points on the tips of the nine to get the square, and the circle obviously on the outside of the tips. And that visually um, just kind of told me like, okay, this one looks right. Um, so I did some, pulled out a ruler and measurements and did some calculating using the formulas and for area of a square, which is the easier one, and then the area of a circle, pi r squared. And it was like so close, even with my calculations using a ruler, and I can't quite get to, more accurate than like 5/30 and stuff like that, right? In today's instruments, of course, you can get far greater accuracy, but just with my measurements alone, I realized like it's really close and close to the the third or fourth decimal kind of thing, with what is available to me here. So that's it. It was a strong indication that okay, this could be it. This could be the the squared circle, um, using geometry in a plane. Um, so that's the logic here. That was my second step to where I thought, okay, now I'm onto something here. So that was that one. And then, oh, let me go back one here just for a moment. In here, when I realized I found something, out of curiosity, I wanted to see, okay, these points here where the square meets the circle, right? And there, I was like, oh, wait a sec here. What's the angle in here? And it turns out it's exactly 36 degrees. So it's 36 degrees in each quadrant, and the ones in between are exactly 54 degrees. And then I realized you don't actually even have to do it this way to, do 4 overlapping 9s to find the square of a circle, because this revealed to me what the actual angles are. And then I realized that the 36 degrees for 4, quadrants will work on any size circle. Any size circle. And you'll get the square for the circle. And I was like, whoa, this can't be that easy. I mean, it's ridiculously easy. Once you've reverse engineered and done all this, like, and I've been brainstorming periodically on and off. I have all these geometrical things always going on in my head, and this one I've come to a few times, and I've tried different ways, and I thought, oh my God, this one seems to be the best one of them all. It's just ridiculously easy. Once you know, right? Once you actually know what the angle is. So if you have any size circle, and you draw your 4 equal quadrants, you just simply measure up from each of their 27 degrees, from there 27 degrees, 27 to there, 27 to there, and you'll get 36 in between. And so if you join those lines, you'll get those points. All the way around, and that'll give you your square. I was like, oh my God, this is just too good to be true. It's ridiculously easy. I mean, granted, you might need a protractor, or you can do any size circle and find 10 equidistant points, right? So you get, and you use two 36s that are going to be opposite of each other, and then you can find the two that way, and then once you've got those two, then you can find the other two that are perpendicular to it. So I mean, basically, you need to find. I mean, you can work either way around. You want to find the 36 or you want to find the 54, but those are in between there. For those 2 points are 36 degrees, and in between those 2 points is 54 degrees. So that gave me more information on how to get a squared circle. And then, as I did this one up, I thought, oh, maybe I'll do a little video on this and share this. I started messing around in here, looking around, and I realized if you connect a line from the corner of the square to the middle of a square, okay, and you do that again from the middle of a square to the corner of a square, where they intersect, and also the diagonal, right? All three perfectly intersect right there. And that happens to give you a perfect equilateral triangle. I thought, man, what are the odds of that? And then I realized you can do this the other way around. If you are starting with a square and you want any size square and you want to get the circle of equal area to the square, that's all you need to do. You draw a line from the corner to the middle to the corner, and of course you could do the diagonal, and then you get that reference point there. And then you just go from there and find your equilateral triangle. So you can do this going from a circle to a square, or you could do it going from a square to a circle. Any size circle or any size square. Now that once you know those things, but the harder one, of course, is going from a circle to the square. But now that I found out it's 36 degrees. You need 4 36 degrees to get your reference points for the square. And that's how easy it is. I think I've explained everything I've just found, and I've just all of this stuff I've just found it in the last 2 days. I was actually doing something else, and then I got sidetracked into doing this. I was like, oh, I got to finish this anyway and see where it goes. So, and this is where I ended up. So, very interesting, very interesting. I thought this is ridiculously easy if this is the case. That this is how simple it is to find the equal-sized square to a circle. Without having to verify that through complicated formulas and such. I mean, if you go on to the wiki, for example, there, and you look up squaring the circles. I mean, those are some really complicated and I'm not even sure if those are um, um, accurate enough. I mean, those are, of course, man's curiosity and the lengths that he will go to. But some of them, I must admit, some of them just seem rather ridiculous. But hey, A for effort, But I don't think that is the more logical way to do this. Geometrically speaking, I mean, that was the question I've had for a long time. Like, there must be a geometrical way of finding an equal size square to the equal size circle. I mean, there has to be. Of course, it does have different context of metaphysical elements and metaphorical elements and that kind of thing, squaring the circle. And most people are aware of that. But I thought at a foundational level, if you are using geometry, okay, if you're showing me geometry, I don't care if it's a triangle, a square, or a rhombus, or a parallelogram, or a 7-sided, or 8-sided, or 9-sided, or whatever it is. If you're showing me geometry, there must be a geometrical answer as well. It cannot be just something that is left up to something metaphysical and just remains in the ether forever. Personally, I just felt that's kind of ridiculous. But anyways, here we are, and long story short, I'm going to end this. That's it for today.